This is video on kinematics of particles. This is the second video. We have said part 2 out here, and it's about straight line motion. And here the data is given in graphic form, and answers are also expected in graphic form. There are going to be a couple of videos of this type. This is the first video. Have a look. Here the data is given in this manner. There is a ST graph, meaning a particle is moving along a straight line and its distance from the origin varies with time in this fashion. For first 10 seconds the variation is parabolic and then it is a straight line. Now what you are required to do is, using this data, you are required to plot Vt, that is velocity time graph, and At, that is acceleration time graph. So let's go about like this. Let's look at first 10 seconds. Okay. In this, s is equal to t square. So differentiate it, you get v velocity as 2t. So your Vt graph up to 10 seconds is 2t. Let's do the same thing from 10 to 30. S is equal to 20t minus 100. So your velocity is, if you differentiate, you get 20 constant. So your Vt graph in the portion 10 to 30 is 20. This information, let's put it on a plot. What we get is a Vt graph. See, for first 10 seconds v is equal to 2t, and for then on v is equal to 20. So we have managed to create Vt graph from this data. Let's do the same thing for At graph. So what we do, v is equal to 2t we already have here. You differentiate it, you get acceleration as 2. Then for this interval 10 to 30, you have v20. Differentiate it, you get a0. So At graph will consist of a equal to 2 and a equal to 0. We put it in the form of a plot. What we get is, for first 10 seconds is 2, and then it is 0. So we have created Vt and At graph from the ST graph. Then next problem we are going to do exactly reverse. That is, from At graph we are going to create Vt graph and ST graph. So the statement of the problem goes like this. A particle starts from rest and travels along a straight track such that it accelerates at a constant rate for 10 seconds and then decelerates at constant rate. Draw Vt and ST graph up to 60 seconds. Fine. So let's concentrate on first 10 seconds. Here a is 10. Accelerator given. A is dv by dt. I integrate it. What I get? 10t plus c1. Now this c1 I need to evaluate, constant of integration. I have the information. Starts from rest. So at t equal to 0, v is 0. So c1 comes out 0. And I have, for my Vt graph, first portion v is equal to 10t. For the next portion, a is minus 2. So I integrate it, I get minus 2t plus c2, and c2 I need to evaluate. See, at t equal to 10, see here, t equal to 10, v will be 100. So if I plug it here, I'll get c2 as 120, and my equation or my plot for this interval 10 onwards becomes minus 2t plus 120. So if I plot these two, I get something like this. Up to 10 it increases, then it decreases, and 60 it so happens that it becomes 0. So this is my Vt graph. Now I have to create a ST graph in the same manner. So what I'm going to do is write v as 10t, realize that it is ds by dt, integrate it. I get s is 10t square by 2 plus c3. It starts from origin. So t equal to 0, s equal to 0, so c3 is equal to 0. And therefore, I get s as 5t square as my first portion. Then I use this, v is equal to minus 2t plus 120. Realize it is ds by dt and integrate it. I have integration constant which I evaluate, knowing at t equal to 10, s will be 500. So I work out C4 as minus 600 I get my equation, and then these two, s equal to 5t square and s equal to minus t square plus 120t minus 600, I plot and I create ST graph up to 60 seconds. So see, uh, sorry, see, this portion is your s is equal to 5t square, and this part is s is equal to minus t square plus 120t minus 600. So we have really handled the graphs forward and backward. Okay, so this is sometimes, instead of only analytical equations, they expect you to handle the whole thing graphical in this manner. Thank you.